Hey everybody, thanks for tuning in. In our last video, I left you with this. Okay, this enemy, just a bunch of code that didn't really do anything. But today we're going to take this code and we're going to make it work by recreating our basic slime. And so we'll end up with this. Nice little slime. He works just like our other slime does, but maybe even a little bit better. Hi, my name is Michael. Join me as we build an epic Metroidvania game in Godot 4 using GD script. This is the Metroidvania Forge. Alright, so in the last video we really took a deep dive into building the scripts that you see on this screen here, or I should say represented, that these nodes represent, right? So in this video, we're going to wrap up that job and we're going to make a new version of our slime. We've got a slime 2 here. We need to hook him up and make him functional, which means we're going to have to add a decision engine for him, as well as some states that will support him for the new enemy state machine that we've built. And let's go ahead and get started. To start, I want to do a little bit of housekeeping. I noticed I have some warnings popping up in my debugger, and one of these is related to this edge detector script. I'm going to go ahead and close everything else right now because we're not using Delta, so we can just give that an underscore, and that'll clean that up. I don't know if you've got this same error. The edge detector script was something we built in episode 1. Now we're in episode 3. Now this other area, I'm a little bit worried about, but it should be easy to fix. This is on our player script. You can see that on our on damage taken, we are using a parameter name of attack area. And you can see down here that the warning is that attack area is shadowing an already declared variable in line 18 of the same class. So if you look up here, it's because we've named the player's attack area with that same name. Okay, so in order to be safe, this could very well be causing issues. I don't know. I'm going to go ahead and just call this A. And then here, we're going to say A. I think otherwise what might have happened is if an enemy attacks the player, it would potentially be getting the damage from his own attack area as opposed to the one on the enemy that may have damaged him. Okay, so this is an important little fix here. And once we save those and run the project again, it should clear them out. Okay, there we go. Cool. Nice to clean up some little warnings. And this particular one was definitely potentially an issue. Okay, so now we're going to start by working on this enemy. Now, in order for him to work, we need to add some states and we need to add an actual decision engine, because right now we don't have one, and the only decision engine script we've built is essentially a placeholder, right? Same with our enemy states. And I want to introduce something new that is even new to me. In the past, like when we were building our player states, we would copy something. I would always do something like copy the idle state, change the class name, and then clear stuff out. And I realized that there was something off about that. And so like when you go and create a new script, you can choose a template. And I had the thought, oh, I bet you Godot supports us creating custom templates. And sure enough, they do. So what we're going to do to start is we're going to create 2 custom templates. We're going to create one for our decision engine so that anytime you need to make a new decision engine, you can use that template. And likewise, when we're creating new enemy states, you can use the enemy state template. This will mean that when we set them up, they'll be clean exactly how we need without naming conflicts, etc. It'll just make it a little bit easier, okay? So in order to do this, we need to go to our root folder. So it's going to be called resource, probably, right? And we're going to create a new folder. Now this folder name has to be exact, I believe. This is going to be called script templates, like that, okay? Script underscore templates. And then what we do is whenever we're creating a new script, Godot is going to check in here for any custom templates we've added. Now, in order for this to work, for each script that has templates, we need to make a folder that matches that class name. So we're going to have decision engine. And I believe this does need to match the capitalization and everything. So this is one situation where I'm going to break naming convention in my project. So I'm going to call this decision engine with capital D and capital E and no underscore. Okay. Because that's what, if we go back to our decision engine, you can see that's the class name we've got here. Okay. Now, lastly, within this decision engine folder, we can create a new script. This first script is going to be painful. Well, not really. I'm going to start like this. I'm going to start with an empty script. And did I not give that a name? Here, let's delete that. And I'm going to close that. I don't know what I did there. Discard, decision engine, right click, create new script. Oh, I guess, yeah, I don't know what I did. Okay, so we need to give this script a name, right? And now I don't think this name matters too much. It's going to be essentially just viewed because it's a child of this. So you could have multiple templates from what I understand. Underneath this decision engine folder, you could have like 3 or 4 templates if you wanted to. We don't really need that, but theoretically you could. And there's ways to distinguish them that I'll show you once we get building this. So I'm going to call this script decision_engine_default, like that. And okay, now I can delete all that and save it. For some reason, okay, this happened to me before actually, and I thought I was doing something wrong. And you just watch me do this again. This says unsaved. I'm going to close this unsaved one. Discard that. You can see I have a file in here. Now I need to open that. I don't know if I'm doing something wrong. You guys can help me out. I think it has to do with the fact that this script is in the script template folder, and so it's kind of being omitted from certain Godot functionality. So yeah, if you have what I had where it opened that unsaved version, close it, then open this again. Okay, there we go. Make sure you're working on this file that it's saved here in your folder, not whatever it opens. And again, this is actually a cry for help. So if somebody does know if there's a way to make that easier, go ahead and drop a comment. Okay, so what we're going to do is I'm going to come in here. I'm going to comment out the class name because I don't want this to be there by default, but I do want this to be part of the script. So what's going to happen is most of the code that we add to this template is going to be displayed in the script when you create a new one, when you've selected this template. So we do know that this, whatever kind of decision engine script we're making, it does need to extend decision engine, and it should have a class name. I think it's not 100% required, but it would be nice. So I'm going to leave this comment here that you could delete it and then change the name, right? But we don't want it to start with that by default, because then if you save it and you've got 3 or 4 that all have this class name, then you're going to have conflicts. Okay. Okay. So there's a few things that we can add here. We can add some comments, and it's going to help this script be organized in that little dialogue. So we can have some metadata. There's a meta name. And so we can just call this decision engine. Okay. Then we have a meta dash description. And I'm just going to call it something like boilerplate decision engine script or something like that. And there is a meta default, or yeah, there's a meta, yeah, it's called meta default. And I'm going to set it to true. So I believe what this will do, as I understand it, and in my experimentation, whenever you create a decision engine script, it should hopefully recognize this particular template as the default one that it should select. Okay. Now, one thing that I'm going to do, and this is for future me when I'm working, is I'm going to add this comment here. Okay. So this comment is going to say included in the decision engine, and it's going to tell me the variables. So that way I can remember what is part of that class. Obviously, you could click on it and see those, but I think it's nice to just have that as a reference. So real quick, comments will be displayed when we create a new template, except for these meta ones. They're going to get removed. Okay. So what I'm going to do is I'm going to just kind of remove spacing so that I don't have too much. So now what we'll do is for the rest of this script, whatever we write is what appears in this default template. And we're going to say, if we look at our decision engine, we have a ready function, but we may need to do some things in our ready function. And so to make sure that we do that properly, I'm going to make a default ready function that looks like this. Now, this is very particular. You'll notice that I'm starting my ready with await super. We've used the super call in the past, and what super does is it will just run the ready function in the parent class before it runs this. But we're adding the await because it's very important. You'll notice that this particular ready function has this while, and it's got some awaits in here. If we don't add the await on this, then technically this code's going to run before this code potentially, because even if this awaits only one time in the parent, that's already going to be one frame later than the rest of the code here. So we're awaiting super. Once that ready function has fully finished, then we can run our own script here, okay? So this way, if you need your decision engine to do anything else like set up a timer or anything like that, you can do that right here. Now, the only other thing we need to do in our template is add a placeholder decision or decide function. So you can see that, and I'm going to have to change this, but you can see that I've got some comments in here with example decisions, like if our blackboard has a damage source, then, we might want to return one of these states. This line here, I'm going to comment out as well, because obviously we don't have, well, I can just remove this part of it, I guess, but I'm just going to comment it out until it will work. Okay, so you can see this is just an example. In fact, we're going to use some of this. We're not going to use all of this for our slime because we're not going to have a chase state or really tracking the player as a target. We'll do that later in the series or in the chapter when we get to more advanced enemies. But obviously, if the players or if the enemy is dead, or if the blackboard says we can't decide, if can decide is false, then we're just going to return null, okay? So there's just a couple things. The order of these is very important, and that's why I put this example in here. So then when you create a new decision engine, you might just come in here and go, oh yeah, I want that, and uncomment it, right? Because that's going to be pretty boilerplate that you might need. But obviously, if I do that now, I'm going to run into errors because I haven't declared these functions, so I can't do that, okay? And I don't want to declare those here. I want to save that for the specific decision engine. So that's our template for the decision engine. Okay, pretty simple. So let's go ahead and create one more template, and we'll go a little bit quicker with this one. This is going to be our EnemyState template. So I create that folder here in my script templates. I'm going to create a new script. It's going to do this weird thing, I bet. And we'll just call it EnemyState_default. Yeah, look at that. Unsaved. Give me a break. What is that crap? So close the unsaved one, just discard it, and open this guy. Okay. All right. Clear this out. This is how we're going to start this script. So we're going to have a class name. The class name is going to be important for the enemy states, and it'll make it easier to work with anyways. Here's our meta name, EnemyState, boilerplate template for an EnemyState script, and default true. Okay, so I'm just going to copy and paste in what I want from my example that I've got on my other screen. Okay, so this EnemyState class will inherit the following variables: animation name, state machine reference, enemy reference, and the blackboard reference. Okay, we set all that up in our last video. And then here we go. We've got our placeholder functions. They're filled out with a little comment that you can replace with your own code. And we're ready to rock and roll. Okay, let's start by creating a decision engine that we can add to our slime. I'm working on slime 2 here. I do have the other slime open. I gotta just make sure I'm looking at the right one. But I'm gonna come into my enemies folder, and under scripts, I'm gonna create a new folder, and I'm gonna create one for states, and I'm gonna create one, well, there's a couple ways we could do this. We could create one for decision engines, because we might have generic ones, like a patrol decision engine, and it's got maybe some export variables, and it can be reused for any enemy that can patrol. So that's an option. Alternatively, we could create the decision engines in the folder that go with the enemy that it belongs to. And I think in certain situations where it's a one-off, that might be good. Now, I think for this slime, because this is a basic type of decision engine, I'm just going to create a folder for it. Call it decision engines, and let's go ahead and test this default script out. Now, I'm going to warn you, in my experience, it doesn't always detect the default scripts. Maybe we need to do a project reload for it, but I'm going to go ahead and create a new script. And what we need to do is we're going to say that this inherits decision engine. Aha, hey, there we go. It automatically selected it. You see that template changed? You can see it's looking at our project and it found a decision engine script. Cool, let's give it a name. And I'm going to call this, I'm going to name them all the same. So decision engine underscore, and then I'm just going to call this basic. It's the most basic decision engine we'll have. Okay. So now we can create that. Hey, look at that. There's our new script. I think that's pretty cool, don't you? I'm going to go ahead and uncomment the class name and then just change this to basic. Really, the class name isn't too important on the decision engine, okay? But it's there. Cool. Now, even before we fill this out, I could come to my slime and I could do a Control A and I could add a decision engine. And because these are just scripts that we've built, you can see I've got a basic. So I'm just going to add that. And there it is. It's now in the scene tree. It's just a basic node, but it's got this script on it. Now we're going to come back in here later and we're going to do more with this. We're probably not going to use the ready function in any particular way with this particular enemy. So I'm going to go ahead and delete that. We will probably use, like I mentioned, a lot of this, but until we have states in place, we can't really fill it out. So I'm going to go ahead and save that and call it good. Now I'm going to come over to my state folder and I'm going to create a new set of states. Let's talk about real quick the states that we need for our slime. And let's go ahead and just run it. Really, we only have 3 states. So we've got a walk. And this of course, is not a state-driven slime, but we want it to work the same way. So he walks. The turning is just part of the walking. He also can stun or take damage and then eventually die. Those are the 3 states that we need. So I'm going to build those, and those are going to become basic states that we're going to use on a lot of enemies, in fact. So let's go ahead and create these. Let's create a new script under our enemy scripts states folder. And I'm going to call this, I'm going to use a naming convention for these. Actually, I'm going to go ES for EnemyState _ walk. Okay. And we want to change this to inherit EnemyState. See, that one didn't seem to auto detect that, but there we go. Okay. EnemyState. And very good. Go ahead and create that. Now this one, we do want to give a name. I'm going to call it ES walk. And there we go. We've got a walk state. So now we can just come in here and let's create 2 more scripts. We're going to have one EnemyState. Okay, if you do this before you change the name, it seems to work better. And then we'll call this one ES _ stun. And we'll create the death state. Okay, there we go. We've just created these scripts that have used our handy dandy little templates. Excuse me. Let me take a sip of my brand new Dirty Mountain Dew. It's actually really good. Just picked some up today. Bangarang. Okay, here we go. All right, I'm back here at my slime. We've created those states. So what I'm going to do is I'm going to come to my enemy state machine and I'm going to add those. So I'm going to go ES walk. Oh, you know what? I don't think I configured those other states. I don't think I gave them names. Yeah. So this one should be ES death. And then let's go to our stun state and call this ES stun. Very good. Okay, so now I can go back here and I'm just going to add each of these to my state machine. So I want, I've got walk, I need stun and death. This is kind of different, right? Like in the past, we would add a node and then attach a script to the node. In this case, we're just adding the scripts to the scene like this. Because it's just designed to be a little bit more modular like that. Okay, so there we go. We've got our state machine, we've got our 3 states, and we've got a decision engine. Now, of course, each of these states needs some script, some coding, as does our decision engine. It needs some script to tell it what to do. But this is the setup. So what we'll do is, why don't we just start with the walk state, and then we'll go down, and then we'll slowly start integrating them into our decision engine as we go. So I hope you're seeing that all that code we did in the last video is really benefiting us now because we're almost done creating this enemy. Obviously, we can spend some time refining these scripts, but it's going to be pretty straightforward. So let's open the walk state and I'm going to go ahead and remove this. I added this for our own benefit, but we don't have to have it. And in fact, you may not want it at all in your script. So one thing that we're going to do is we're going to export a variable on this state, and this will be our walk speed. And I'm going to set it to 50 for default. Okay. I think our slime was moving at like 30, this guy. Yeah. So we can change that. But this is an export variable on a more generic enemy. So maybe 50 is a little bit more appropriate for the average walker. Now, one thing we're going to do is in our enter, we're just going to play the walk animation. And we're going to do this in a little bit different way. So we could grab our animation player and tell it to play walk. But if you remember, if I look at my enemy, in fact, let's see, let's open that script. We built a simple play animation function, which will make sure that we have the animation before we try and play it. And in fact, we can try and test this print error if we want to. So we'll try that out right now as well. But let's go in here and let's just say enemy.play animation. And let's go ahead and just do test and see what happens. So if we, oh, and we need to add one of these guys to the playground. So let me take this slime. This is OG slime that we're going to be getting rid of. And what I want to do is come down here and if I can never remember where stuff is. Okay, slime 2. Let's drag slime 2 in here. So now we've got slime 2 in the scene. Okay. Now you can see in my output, we have an error, animation missing test. Cool. That's finally us seeing this little script in action here, or not this one, but the one under enemy. Okay. That's what print error does. Not only does it print an error, but it gives you that little red highlight. So you can see just by looking at your output tab that you've got an error, right? Which is really nice in case you're somewhere else. Pretty cool. Let's go back to our walk state. And there's a couple ways we can handle this. So by default, our states have this animation string that's exported. But of course, we don't know what that string should be. And so I'm going to build this walk state in all of my states in such a way that we don't need that variable, but instead that this variable, and I'll just select the walk, you can see it's right here, animation name. This becomes optional. So I'm going to assume there's a default, but if you, let's say on an enemy, you want to use an animation that you named run or shamble or scramble or something like that, you could type that in here, but otherwise we'll have it play walk by default. Now there's a couple ways we can do this, but I'm going to go like this. I'm going to say variable anim is a string, and this is going to equal, what it'll be is it'll be the animation name if we have an animation name, right? Meaning if we filled it out, but if not, else, then it'll just be walk. Okay. So now we can just plug that in right here. Boom, like so. So now when we run this, we didn't enter anything, right? Our walk state is empty, but it will play the walk animation. So if we run this, there we go. He's playing the walk animation, right? Now, if we wanted to, okay, I'm here and I select this ES walk and I could type stun. Now, when I run it, okay, he played the stun animation, which isn't a looping animation, so it stopped. But you can see how that works, right? So now I can clear it back out and it'll just be walk. Okay, pretty straightforward. We're just going to play an animation. We should point out too that the reason why we're getting the walk state is the way our state machine sets up. If you remember, when we create it, we enter whatever state is the current state, which is going to be when this is created initially, it's going to be this first state in the list. So that's important. If we were to put stun or death there, then that's going to be the first state it enters, which would be bad, right? If you put death as the first state. Now you could change that somehow if you want to, like maybe you could add an export variable on the state machine that says initial state, and then you could assign one. There's lots of ways you can handle that. I'm okay with it being the first one in the list. Okay, so let's go back to our walk state and let's flesh this out. We don't need a re-enter or an exit for this state. In fact, we're not going to need these on many states. They're going to be pretty basic, but we do need physics update. The first thing that we do is just set our enemy's velocity. So we'll say enemy.velocity.x equals, and we're just going to go move speed times the blackboard dot direction. Okay. So you can see we're getting, oh, I called it move speed here, but it's walk speed because it's the walk state, right? Okay, so we got our walk speed and we're getting our direction from the blackboard. Okay, so again, remember how we built this stuff last time. If we look at, I don't have an easy way to get to the blackboard script. Let's see. Okay, our blackboard houses this information, the direction being one of them. Okay. So pretty straightforward. Let's go ahead and run this and see if he moves. Indeed, he does. And he falls. I want to go ahead and test some other things while we're just poking around with this. So on our slime, we've got affected by gravity turned on. Let's turn it off and let's run it. Nice. No gravity, flying slime. face left on start. Let's check that out. Perfect. Face is left on start. Okay. So those are working. He doesn't change directions yet. Let's go ahead. Let's implement the wall direction first. I think this will be a standard on our walk state. Anybody who has it will probably want this. We can just do this here in our physics update. So we can say if enemy is on wall. Now, you could technically build this into your decision engine, but I think that makes it complicated, if I'm being honest. So I'm just going to leave it here. I'm going to say enemy.change direction, and then we're just going to go negative blackboard.dir. Okay. Now, what will happen in our change direction, we're going to reset that blackboard direction after this. So the blackboard's going to stay updated. We'll emit a signal, and we're going to flip our sprite. So he should be able to now change directions when he runs into the wall. Very good. I can attack him, but only because he has a damage area on him. In fact, you can see I killed him technically, right? He can't damage him anymore. He took 3 hits. So that damage area and some of that's kind of working, but we need the other states in place. But let's just start with this and let's assume this is good. I'm going to come back to my decision engine real quick. And before I move forward, I want to come up here. This decision engine, I'm going to say, let's take each of these states and let's access them as unique name so that anytime I have states named exactly like this, which they should be when we add them, I can expect them to be there and to work. Okay. So these are my onReady variables that I'm going to use in this decision engine. Essentially, it requires these states. Again, there are other ways you could do this. I think one good option here could be to export a variable for your walk state, and then you could assign any state you want to that. It wouldn't have to be a walk state. It just has to be an enemy state at the end of the day. Okay, so if you want to replace it with run, you could. But for now, let's just start with this onReady. We'll probably use export variables in future decision engines, but this one, we're going to hard code it. And then lastly, let's come down here. Our default state, instead of null, it'll be ES_walk. Okay, so this is going to continuously return the walk state, which isn't going to change how our enemy functions right now, right? Because that's all he does. He starts in the walk state, he stays in the walk state. And our state machine, because we're passing in the same state, it's calling the re-enter function, which if we look at our walk, does nothing. So he just stays in the walk state and just keeps walking. Okay. But that's okay. I mean, that's intentional. That's how this is designed. Okay. I hope stuff is becoming more and more clear about how we're doing this. Now, let's just look at our slime real quick. We have, we need to do edge detection. I'm going to wait. I'm going to hold off on that one. We're going to finish the other states first. So we need a stun and a death state. Okay. Because clearly part of that is working, but our enemy isn't really responding appropriately. So let's go ahead then and move on to stun. And let's define what happens in the stun state. And then we also need to hook up our decision engine so that it utilizes it. Now, our stun state is a little bit more involved than the walk state. We're going to have the following variables: a knockback strength. We're going to have a velocity X, duration, and a timer. In fact, I'm going to make this one an export variable, the knockback strength. And then these other ones are just to kind of help keep track of stuff. Okay, I'm going to go ahead and save this. Now, the stun state's going to get interesting, okay? Because there is a potential, I think, to re-enter the state. We may need the re-enter. And so for that reason, I'm going to wrap all the stuff in the enter. I'm going to use a new function called start, maybe, okay? Which obviously doesn't exist. Let me go ahead and just create this new function up here. There. Now, if we enter or re-enter, we'll just call the start. Okay. And what this is going to look like is we can do kind of what we've done in walk, like we play this animation. Let's go ahead and copy this and go over to stun. Okay. But of course, this default needs to become stun. And we're going to also add an if check here, because in the situation where we restart the state, we need to handle it a little bit differently. So we'll just do a check. We'll just say enemy.animation. This is the animation player .current animation. So we're going to say if our current animation equals anim, whatever we've just defined up here, meaning we're already playing the stun animation, then instead of playing it, we're going to go enemy.animation and then we're going to seek to 0 seconds. So essentially restart the animation, else we'll play it. Okay. So a little minor difference in how we're going to handle the animation. We've got these variables here. We obviously are going to be stunned for a certain amount of time. So that's what the duration and the timer will help us with. Our velocity X is going to help us keep track of the velocity that we apply to the enemy. We're not going to be using a tween. And then the knockback strength is what we'll use to determine the starting velocity of this stun state. Okay. So let's set up each of these as needed. So we're going to need a duration. We're going to say duration equals, and what we're going to do is we're going to grab the animation length of our stun animation. So we'll say enemy dot animation dot, and then there's a current animation length. See that? That'll give us the duration in seconds of the current playing animation. We could use an await here, but because I'm expecting to be able to re-enter this, an await isn't very good. Awaits on something like animation finished can be troublesome if you, I don't know, if you've got, or if you're waiting for a signal, sometimes you'll catch a signal when you don't expect it, and that can be bad. And so I think this is just cleaner to help avoid bugs. And then I'm going to reset our timer equal to 0. Okay, so we have a duration, which is, let's say it's 0.5 seconds for stun, and then our timer is set to 0. So we're going to be increasing our timer until it reaches the duration. And then we need to calculate the velocity. So let's go ahead and make a function for this. Calc velocity. Okay. And what we're going to use for this is we're going to use our blackboard dot damage source. Okay. This function doesn't yet exist. So I'm going to go ahead and copy this. We'll just make this one down here. Now, this damage source is an attack area. So I'm going to call it A, and there we go. Now, in order for this to work, we need to be setting this damage source. So we'll come back to that, but make a mental note. I don't think we've done that yet, but let's finish our start function because there's just a couple more things we need to do. Once we've grabbed this damage source, what we're going to want is we're going to want to reset that. So our blackboard.damage source equals null. Okay. And then we have another thing on our blackboard that is can decide. If you remember, we added that. And I used this state as an example of when we might not want to be able to decide. So I'm going to set it to false. So what this means is these both mean a very specific thing. But obviously, if can decide is false, then we're going to build into our decision engine somewhere. And it's right here. And I'm going to remove this. Actually, that's fine. I can use this now. Okay, so if our current state is death or not blackboard can decide, then return null. That means we're not doing anything, okay? You're not going to make any decisions. Now, you'll notice I do have this particular branch of code up here before that check, and that's intentional because taking damage should take precedence over any state, even being unable to decide, right? We don't want being able to decide. Like, let's say you use can decide for like an idle because he stops and he waits for 2 seconds. Well, we still want him to be able to take damage. So we need this stuff up here. Okay. This is interesting. I just uncommented this block too. And you'll notice that, again, we're looking at our blackboard damage source. So if our decision engine says, oh, hey, do we have a damage source? If so, check the health. If it's less than 0, then enter the death state. Otherwise, if it's greater than 0, enter the stun state, right? Which brings us into what we were writing here. Then we're going to set the damage source to null. I hope this isn't too confusing. It's kind of circular, but you see how going back to the decision engine, okay, when there is a damage source present, we're going to make a decision based on that. That's why we want to, once we've handled that damage source, we want to clear it from the blackboard so that we don't continuously enter this state. Does that make sense? Okay, so the only thing we're not doing at this point is setting the damage source. Okay, and we're not really done with our stun state yet either, but we've properly set up the start. What we haven't done is our physics update and our calculate velocity, but we can come back to those. We will play an animation if we manage to get into the state. So let's figure out how we can do that. To be able to get into the stun state, then it's as simple as assigning a damage area, where is it? A damage source here in our blackboard. Okay, so let's hop over to our enemy. We actually left this out kind of intentionally, I guess, or maybe not, but I didn't want to talk about it and then just leave it hanging. So in on damage taken, what we're going to do is we're just going to do this. We're going to say blackboard dot damage source equals A. Okay, so when we've taken damage, we'll just assign that value right there. We'll do the health tracking here. In fact, we could move this. We could move this into the blackboard, this health minus, but that's okay. I'm going to keep it as is. But there, because we've assigned it, now we should be able to enter the stun state. Okay. Oh, got to chase him. Boom. It's not 100% working properly because he doesn't exit the stun state, but he played the animation. Okay, which is exactly what we wanted. So we're getting close. Let's go ahead and wrap up our stun state, and then it'll make things work a little bit more smoothly. Okay, so we should calculate our velocity. Now, what we're going to do is we're going to set a variable, or actually we have a variable that we've just defined up here, right? Velocity x. So let's just start by resetting it. Velocity x, and I'm going to set it to 1. As the default. Then we're going to do a check because we've got our attack area here. Let's make sure we've got this in the right order. Yeah, we're calculating velocity before we clear the damage source. Okay, but actually we also have, we're passing the damage source in right there. Yeah, so that's important, right? You see how we're doing that? So there's the damage source. Okay, so if the global position dot x is greater than the enemy's global position dot x, then that means he got attacked from the right by the player. So then we need a velocity x to be -1. Okay. And really what this is this is giving us directionality to the velocity. Is it positive or negative? And now what we'll do is we'll take that velocity x and multiply it by times equals, and we're going to use our knockback strength. There we go. We've calculated a velocity. Really, this is just getting a directionality and applying it to the knockback strength and saving that as the velocity. Let's go ahead and go to our physics update. Okay. We have a timer. Let's just increase that by the delta. And now that we're using it, we could remove the underscore. Okay. Okay, so timer plus equals delta. We're also going to take our enemy's velocity x. We're just going to update the x on this and make it equal to the velocity x times. So what we're going to do is we're going to decrease the amount of knockback over time. So it'll be a smooth slowdown. It'll be kind of like that tween we made on the original enemy, but this time through code. So we're going to do 1 minus timer over duration, right? Because timer divided by duration is going to give us a number between 0 and 1, and we'll subtract that from 1 so that it starts at full strength. And then by the time we're almost done with the animation, this will be like 0.9. So then it'll be like 0.1 will be the result. So we'll just get a fraction of the velocity. It'll decrease over time. And then lastly, we'll do a check. If our timer is greater than or equal to the duration, then we know that we should no longer be stunned. So we'll go blackboard.canDecide equals true. Awesome. You see how this is going to make it so that suddenly, because our canDecide is enabled, when we look at our decision engine, it's going to make it past this point again. Okay. And we've cleared the damage source that he took, so that's not going to hit that condition. It's just going to be waiting for him to be able to decide, unless he's dead. If he's dead, no more decisions, period. Okay. Okay, so let's go back. There's one last thing I want to do. I'm going to copy this blackboard canDecide. I'm going to put that in our exit. Anytime we set our canDecide to false in the start, or in the enter, I want to make sure we do it in the exit as well, just to be safe, so that we don't break our decision engine. So now we should have some added juice to the stun. Nice. And he re-enters the walk. Okay, because if you look at the flow of our decision engine, what is the next thing? Once he doesn't have a damage source and he can decide again, he's inevitably going to enter the walk state. Okay, makes perfect sense, right? We don't need this stuff, sadly. But there we go. That is a decision engine. We obviously haven't hooked up the death quite yet, But this is it. This is a decision engine. You can see how this is just a simple function that allows us to apply the logic, but it just depends on external sources for information and decision making. So it really simplifies and breaks out that code. Is the last video starting to make sense? I hope it is. I hope that this feels good to you guys. I'm pretty happy with this system. Maybe it could be improved. You know, you can drop some comments. This is a good opportunity to ask for that. So go ahead and give me comments and feedback on how I'm doing with this video and with these enemies. I know that building enemies is complex and there's many different approaches. So I hope you guys are enjoying the approach I've developed here. Okay, let's hook up the death state. That's the last one. We've already included it in our decision engine, and in fact, we even have conditions to arrive at the death state. It's just that our death state is empty. It doesn't do anything. Okay, so let's figure out what we want it to do. One thing that we're going to do with the death state is a lot like our stun state. In fact, I'm going to go up here. I'm going to take these variables. I'm going to copy them, and I'm going to put them in the death state. You don't have to do it this exact way, but I like this. We want a knockback strength, so we'll have the same way of kind of handling those. In this case, we are going to use the timer and the duration for the same way that we used in the stun. So we could actually come down to our physics update and actually set this up. Okay, so something like that again, right? Remove the underscore from my delta. So that's going to kind of work the same. What is the difference here? Is there any difference? Not really. It's identical. Okay. So we're going to be doing that same thing. We want the same calc velocity. These functions could become maybe more generic functions on some other class if you wanted to, but we're going to keep it simple and keep it in the same script for now. Okay. And you may want it to do a different velocity calculation anyways. So I'm going to go ahead and save that. No, I'm not going to worry about having a start function because we're not going to be able to re-enter. Death state is pretty final. Okay. But we will have an enter function. And we're going to do this one a little bit differently, but we're going to do kind of the same thing. I'm using a shorthand here. So instead of assigning a variable for the animation, I'm going to say animation name, if animation name, else death. So this is just taking, let's see, essentially this part of the code and plopping it in right here. Okay. So just a shorthand. You could write it the other way as well, but we're only going to be playing the one death animation. Now, one thing that I have here is I have playing the sound, and I'm just not sure where I want to do that because I guess when we built this enemy, I added the death sound right here. And you know what? I think I want to remove that because I want to keep the enemy as simple as possible. Okay. So what we'll do then is we'll add the death sound here. So we're going to have another export variable. And let's just call it death audio, which is an audio stream. Okay, and then we can play back that audio using our play spatial sound. This is a fun opportunity. I don't know how many of you guys saw, but I added this pooling functionality to this. It's like a chapter 3, episode 9, even though I really just released it the week of the recording of this video. So, you know, you can go back and do that if you want to, but it's not required. It'll still work regardless either way. Okay, so we're setting our duration and our timer, calculating our velocity, just like we were before. We can clear the damage source, set can decide to false. This is almost not important because he's in the death state, but it's safe, I guess. And then I am going to use the await animation finished on this one. I know last time I said it could be problematic, but because we're not going to be entering any other states after this, I think it's okay. And so what we'll do is we'll queue free the enemy once the animation has finished. And so, you know, we don't have, let's go down here. Let's go down to on damage taken. You'll notice we don't queue free the enemy here in on damage taken. We're going to let the death state handle that. Okay. This death state is probably going to be pretty standard for most enemies because it doesn't need to do much else, right? The only reason it might be different is if you need to add something fun or unique to it, or maybe you want to have, you know, a death state that transforms to another monster or something like that. But otherwise, you know, you could just use the knockback and adjust it appropriate to the enemy that you're killing, and make sure that you come in here and set an audio. So here we're going to use the slime death audio, and there we go. Okay. So at this point, we should have a functioning death state for our slime. So let's go ahead and test it out. And there we go. Perfect. Slime be dead. Okay. Cool. We've utilized our new state machine. We've built a custom decision engine. And there's really only one last thing to look at. And we're only going to dip our toes into this topic in this video, but it's the topic of sensors and how those will integrate into our state machine or into our decision engine. Okay, so the thing that we have is we've got an edge detector. This is a sensor, right? In fact, I'm going to make a new version of this edge detector because this particular script is really written kind of generically, but I want the enemy sensors to be a little bit more designed for the enemy system that we've built. Okay, so let's make a new version of the edge detector. Okay, let's do this here in our enemy folder. So just under scripts, let's go ahead and create a new folder for our sensors. Okay, I know we built this edge detector here, but whatever. I'm going to create a new script, and this will be called, and actually it needs to extend raycast. It's not working. Raycast to D. It should inherit that. Am I just spelling it wrong? Capital C. There we go. Okay. Now let's go ahead and give it a name. I'm going to call it edge_sensor. Okay. Now we'll give it a class name. And yeah, it extends raycast 2D. I want to look at my edge detector. I'm going to take this icon, copy it, and I'm going to paste that here as well. Okay. Okay. So let's look at the edge sensor. Actually, the edge detector, some of this is worth keeping, like this signal here. I'm going to copy that and paste it in here. We do want the edge detected signal just in case we need it. And the colliding variable, that's also good. I want to add a reference to our enemy. Okay. I don't want process. I want to use physics process of here, just like we did. Really, I mean, the majority of this is going to be just like our edge detector, okay? So let's go ahead and start with the edge detector. And maybe what I should do is I should just copy all of this code and come over to the edge sensor and replace this, okay? So we're still going to do our collision mask setting. We're going to do something slightly different in our physics process. We'll also do direction changed. How are we going to trigger these? So right now, like if we look at our slime, let's look at the old slime. You remember here in the old slime, we got a reference to our edge detector, and then we call them directly. In our new generic enemy, we don't have the edge detector in here, but that's okay. That's by design. We're going to make it a little bit more autonomous. Okay. So we do have, though, the ability to check for a direction changed signal. So if we go to this new edge sensor, what we can do is we'll do a check here. Now we're going to use if owner is enemy. Okay. So what that says is the owner is going to be the scene, the root node of the scene that this belongs to. So in the case of our enemy, it should be something with an enemy script. Okay. Whatever that root node of the scene is. So if the owner is an enemy, then we'll set our enemy equal to the owner. And then we will go enemy dot direction changed and connect here. Okay. And then we already have a function, and I'm going to rename it to on direction changed. Okay. Go ahead and take this up here. Boom. There we go. So now whenever the enemy changes direction, we'll still do that same position change that we built in our previous edge detector. But if we don't have an enemy as an owner, then this node won't function. So we'll do an else statement, and we're going to set our physics process to false. And then I also want to enable, set our enabled equal to false. Okay. In fact, we could probably just queue free this. I don't know. But maybe we're going to re-enable it later. So I think this is good for now. Okay, there's our updated ready function. Just added this bit of code. Now, really all we need to do is come to our physics process, and we need to update this as well. So I'm going to build in a few extra things. One thing is I don't want this edge detector to be working when we're not on the floor. So we're going to say if enemy dot is on floor, and I'll change this to a not. So if not enemy is on floor, then we'll return. Okay. That'll help us not worry about edge detection when we're falling. Now we've got this is colliding variable that we're determining here. We're going to keep that as is. We're going to keep this as well. If colliding does not equal is colliding, right? We've just got this variable here that we keep track of our collision state. And if it changes, then we're going to handle it. Now there is a difference here. So we have this edge detected signal that we will emit. I'm going to maintain that because I think it's smart to have, but that's not going to be the primary mechanism through which this edge sensor will work. Instead, what we'll do is we're going to grab our enemy and then grab the blackboard. And then we have in here edge detected equals true. Okay. And then we need an else because this could also need to be set to false. Okay. Because, yeah, if it was colliding when it changed, then edge detected is false. Or, yeah, if it's colliding, right? There we go. So there's our update. So now instead of relying on this signal or anything like that, we're going to be just setting a value in the blackboard. So right now, this doesn't actually change our enemy behavior. He's still going to walk off that platform. But what we'll do is we'll come into our decision engine and then right here. So if he's not dead, right down here, before we emit the walk, we're going to do a check if blackboard dot, and then we have edge detected. Now we can do something. So you could do different things here. For our basic enemy, he's just going to turn around. So we'll do enemy.change direction, and then we're going to do negative blackboard.dir. Okay. So we'll just do that. But you could have something here where maybe the enemy stops and idles for whatever, a few seconds or something like that, right? You could replace this with a return and return a new state. Okay. But there we go. Now, pretty simple little decision. Uh-oh, didn't work. Why this not work? Oh, because we have an edge detector in here, don't we? And we just created a new thing called an edge sensor. So let's add the edge sensor. And you'll notice I'm not going to even do anything with it. Well, no, we should. We do need to configure the location, maybe. And I'm going to shrink that ray. Doesn't need to be big. Okay, let's try this again. Please work. There we go. It works. Okay. So this decision engine works with an edge sensor, even if we don't have it. Right? I mean, obviously it doesn't work if we don't have it, but it doesn't require us to like connect directly to the edge sensor or anything like that. We're really decoupling our code and making it loose. Loosely coupled code can lead to confusion like I had when I ran, right? Like I didn't get an error. Why is my, why did it not work? It's because I had the wrong kind of edge sensor in there. So you need to change it. But generally there's power that comes with this too, because our code becomes less fragile, less brittle. It won't break on any little change. Okay. So if you needed to update how your edge sensor works, that's fine. You just need to make sure that you communicate the status appropriately back to the enemy or the blackboard, right? But you could change everything about how this works. You could make it not a raycast 2D and do all sorts of stuff, and it could still potentially work because all you have to do is make sure that you update this edge detected value on the blackboard, and now your decision engine knows how to handle that. But the decision engine doesn't know how the edge was detected or how that got set. And frankly, neither does the blackboard, but it doesn't really matter, does it? Because it just matters that we use the tools in the way that they've been designed to be used. Okay, so there you go. A challenge for you. Bit of homework. I think the next thing that you might want to do is see if you can adapt this to a slightly more advanced enemy. Now, no doubt some of you have enemies that you've already designed and are looking to integrate. And so maybe you have an enemy that needs to be able to attack. Maybe you simply want an enemy that chases the player when he sees him. And so you need to develop a new type of sensor and figure that out. Whatever the case may be, I want you to give it a whack and see what you can come up with. Now, the next video that I release should be the enemy showcase video, which is going to be fun. It's just going to be kind of like a community event style video. I'd love to do it live stream. I just can't I can't commit to being on camera during the time I'd like to have this come out. So it'll be probably a premiere. I'll probably be in the chat watching it with you guys when it launches. And those enemies, we're going to be using some of them and bringing them into the project here and adding the states and whatnot that we need to make them work. So that's going to be a lot of fun. We will be building like a player sensor, which is like a vision cone or some type of enemy sensing the player. So we'll build that. So if that's one that you're wanting to take a whack at and you fail, then don't worry. I'll give you a solution that I've come up with that will work. And yeah, we'll be adding things like enemy attacks, enemy chasing, probably things like enemy idle, and whatever else we come up with as we look at these enemies. So thank you for following along. I hope that this video helps solidify this enemy system in your mind. Really, from this point forward, it's just going to be expanding upon the system and building actual enemies, right? But if you just stopped here and used this system to build your own thing, then theoretically and hopefully you would be able to build any enemy that you want. So thanks again for watching. Go ahead and drop a like if you appreciate this. Subscribe if you're new so that you can see what's coming next. And as always, we'll see you next time.